Okay, so we learned how to do long division yesterday, and today we're going to learn a shortcut. This thing is called synthetic division. What synthetic division does is it divides it, but much quicker through an algorithm. So here's how the algorithm works. The first thing you want to do is take your divider, and then go about what number could you plug in for x to make this whole thing become 0. Hopefully you realize that that number would be 2. So what we do is we're going to take that number and we're going to put it in this little box up here. Then we're going to take our coefficients. And our coefficients for this would be 3, -5. Well, if there's no number in front of the x, I'll give it a number, which will be 1. And then we're going to do 2. What the algorithm does is it divides this thing for us just in a faster way. So again, last time, we tried to make sure that these cubes and squares would all equal out by timesing, but really what we mostly cared about when we were dividing is to make sure this coefficient would get 0. So when we're doing this, the first thing you're always going to do is you're going to take that first coefficient and just drop it down. Then we're going to take the number up here and times it by this. So I take that number and times it by this. And that would give me 6. And then we add. So -5 plus 6 would give us 1. Again, I do the same thing. So 2 times 1 will give me 2. And 1 plus 2 is going to give me 3. And then I'll do the same thing. 2 times 3 will give me 6. And then 2 plus 6 will give me 8. And you might see that we just have a string of numbers. I always like to cut off this last number here. And this is how it works. The biggest coefficient, these things are just 1 degree lower. So that would be a degree 2, this would be a degree 1, this would be a degree 0, and this would be my remainder. So when I take my final numbers and I rewrite this stuff, I would get 3x squared plus 1x plus 3, and this thing has a remainder of 8. Okay. So again, the synthetic division process happens by taking all the coefficients, putting them out here, figuring out what would make this equal 0, putting it up there, carrying down your term first, timesing these things, and then adding them together, and whatever's left over, you will get your answer. So this would be my answer. Let's try another one of these. Again, for this synthetic division, our first step is going to decide what would make this thing become 0. Hopefully you realize that would be -1. Now we're just going to set this up. The terms that I would have would be these things in front. So I'd have 4, 3, 7, and -1. And again, I'm going to already separate this stuff because we know that this should be our squared term because it's 1 less than this. This will be our first term, and this will be our 0 term, and this will be our remainder. Now, the first step for this thing should be taking this 4 and carrying it down. So I'll have a 4 here. Then I'm going to take this -1 and times it by that 4. Get -4. We add these two things together. So 3 plus -4 will give me -1. Then I'm going to times that. -1 times -1 will give me a +1. 7 plus 1 will give me 8. Then we're going to times it again, which will give me a -8. And -1 plus -8 will give me a -9. When I rewrite this again, I'll have 4x squared minus 1x plus 8 with a remainder of -9. And as you can see, this is a little bit faster than setting up all that long division and doing the subtraction and different things. So it's another way for us to do this very quickly. Let's do one more example. Okay, again, my first step is always the same. I want to think about what would make this bottom part 0. And what would make this divisor 0 would be -3. So that's going to go here. Now we have an issue with this. It skips all the way to x cubed, all the way to my regular number. So I kind of have to rewrite this into a nicer form, which would be x cubed plus 0x squared plus 0x minus 4. So that we don't skip these two middle terms, because those things are still coefficients. So my coefficients for this problem would be 1, 0, 0, -4. And let's use synthetic division. Again, you drop down the 1. We would get -3. 0 plus -3 will give me -3. I'll times that, and I'll get a +9. And then we add those down, we'll get a +9. And then -3, we'll get a -27. And that will give me a -31. So again, if we kind of write this through, this becomes my x squared, this becomes my x, this becomes my constant, and this becomes my remainder. So I'd have 1x squared minus 3x plus 9 with a remainder of 31. Try the different problems today using the synthetic division. I know that this method can be a little bit confusing to figure out the pattern, but once you figure out the pattern, you can see that this thing goes pretty quickly. I should have wrote -31 here because that's what I had, but yes. But the pattern goes pretty quickly.